Hello everyone. Welcome to our a little rushed, albeit, but also a very interesting lecture that is happening soon. Very soon. I am here with Arjan from the Hanze, Arjan van Havelingen, and with Anne Vining. He is my business partner for Den of Thieves. I think Arjan can kick us off quickly.
Today we're gonna dive in a bit where I am just really a noob, and so I'm keen to hear what you guys have to say about why your code sucks. We're very happy to give you to help out and give you the stage, or at least promote you talking about how to set up writing tests to make sure the backend is good. Vasil, I've known you from a study of game design at Hanze, and Anne, I've met you in the network, someone who's really active in the coding part. And it's really nice to see that you can give us some pointers, something to learn. There's always more to learn in games. It's a very complex medium. There's a lot to do. And great that you guys can share some insights so the rest of us can also improve our pipeline.
There absolutely is. Yep. I have been told our audio is only in the left ear, so I am attempting to fix it right now. But thank you very much for the introduction, Arjan. Here's the other test. Here's me. Hello, everyone. And we will go in a bit in our lecture, as it is here, explaining why your code sucks. But before we actually start talking about code and all of that really fun stuff, we wanted to say a bit about ourselves. So I'll give it to Anna, and he can explain a little bit about him, me, and our company.
All right. Hello, everyone. This is Anne Vining. If the video switches, I hope it did. All right. Hello, everyone. Thank you all for coming to today's stream. I'm very happy to see you all here. We're going to be talking about unit testing, and I'm very happy because this is something that's very close to heart. At Den of Thieves, we work a lot with foreign code bases. That is code that we didn't write ourselves, and we've developed a few techniques and a few ways of handling this over the years. Definitely something that's very close to my heart. Sadly, due to Corona, the entirety of the lecture will be given by Vasil, who has gracefully been allowed to hold the lecture over at Ethiopia. So special thanks to them. And I guess Vasil can take it from here.
Absolutely. Thank you guys for the introduction. I do want to reiterate what was just said. Thank you very much to Utopia for letting us use their nice studio with the green screen that we set up very quickly and haphazardly, but it includes all these nice microphones and headphones that we can make sure that everything works properly and goes accordingly. It is open for use for people who are interested, so you could get in contact with Utopia or with me. But for now, let's get to unit testing. So, as was already said, we do work with foreign code bases, with basically code that other people wrote. That could be for older versions of Unity or for other engines or whatever. But it's very important that we can decipher how everything works so we can safely make changes. And this is the point for unit testing. It's really valuable when we are making changes to additional code, especially if we haven't written it ourselves. But especially with games, the more features we add, the more code we write, the more complicated everything gets, and at some point it's impossible to track everything. So this is why this is important, and especially for us, we'll be working with a variety of interns. We have different people contributing to the code, and it's really important to have some functions in place which keep everything together from exploding and breaking. So if I can continue here, streaming is really not good on my laptop. But basically there are two ways of introducing changes to code. The first one everyone is familiar. That's something people have done before. It's called edit and pray. So the typical scenario when we start programming something or changing something we've already programmed is we go down and we write some code, as we do, and then we have to see that our code actually runs. Of course, we can write all we want, but we want to see the results of our labor. And then we have to play around. We have to actually see if it works. And that includes going into play mode, going into the editor. I think it can be pretty obvious that this kind of sucks, because to test one small feature, like one single algorithm that we've written, maybe just one function in one class, we have to compile everything, we have to start the game, and we have to somehow interact with the whole thing. That is problematic, especially because there are some functions, there are some features that we cannot test just from clicking around in game mode. There are some things that are backend, or some things that we still have to program an interaction for. This is the example that we'll go into briefly in the future. And so we don't really need to have such a long action chain just to test one very simple thing. Many features are untestable, and the more thing we have, so the more functions that we have in one project, the more painful it becomes to change or add anything, because you don't know how the rest of your code will be affected. This is why everyone does it for some reason. That's because no one knows better. It's kind of the most intuitive, standard way. But there is a better way. It's okay. Everything is fine, because imagine a world that is happy, a world where everyone can work together with no problems, a world where world peace has been achieved. And most importantly, a place where developers are happy people and they smile. Look at this guy. He's so happy. And that's what we want to be when we program, and when we program anything, and when we develop games especially. We want to be happy. And what is this world? This is the world of unit testing, of course. So the second way of introducing changes to code or writing new code is to cover and to modify. Cover, of course, refers to covering your code in a sort of safety net. Those are the tests that we'll be talking about. A test is supposed to be a vice. It's supposed to hold a small piece of code, a singular unit. That's why we call it a unit test. It's supposed to hold the unit of code, and to give you indications of whether the change you've made is affecting things. It lets you check at any moment, just when you decide to run your tests, what the effects of your changes have been, if everything is working as it should be, and if it's working as it should be in all scenarios. And generally, if your code is getting better or worse, if you're worried about that sort of thing. Here I've written a little definition of what a unit test is. It's a piece of code that runs separately from the rest of your project that validates if a specific method functions as expected. So it's important to say that this is code that we write as programmers that checks code that we've already written. It might seem a bit counterintuitive to write code, to check for code. Aren't you doing work twice? But there's really no way to safely add new code, especially on big projects, if you don't know how the rest of your code is affected. And this is why we have to write these very simple, very small tests. They're very simple. We will write one today. If everything works, fingers crossed. And so I will show you that it's not that big of a deal. Yeah. And so here is a very simple example of a unit test. You always have to give it an attribute test. That is how it communicates with the framework. Nothing you should worry about. And this, for example, is a test which does damage to the player and then checks if damage has been actually done. Essentially, it tests if your take damage function operates properly. Because if it doesn't, this test will not pass, and if it does, this test will pass. You might see the name of the function and freak out a little bit, but it's really important how you name your functions in general and specifically for tests. The name has to consist of 3 distinct parts. That's how many people and many professionals recommend it. Even if you go on Microsoft's resources, this is how they say it should be. The first part should be the name of your method. The second should be the scenario under which you're testing your method, your function, and then the expected result. So if we see the one that we just had, we have a function test damage, which we're testing. What we're doing to it is we're removing 10 HP from the player object, and then we are expecting to receive the health being 9, the health being 90, and then that means that the test will pass. If we remove 10 HP and the health is not 90, the test will not pass. So this is what this function does. So this was a brief introduction of what tests are, and after a short Q&A, after a quick break, maybe sort some technical issues too, I will be sent some questions that I can answer. Then we'll actually go into the actual programming coding part. We'll go into Unity, and I'll show you how to do a very simple test of your own. For now, let's have a quick break. I'll collect a few questions to answer, and I'll be back in a bit.
And a question, when would you use unit testing instead of other methods of testing like breakpoints?
So breakpoints, those are mostly used for debugging.
It says so here, yeah.
Yeah, you use that to kind of chase down a bug. Unit testing is more of, well, as Vasil described it before, it's a vice. It is a method that holds something else in place. So say we have a button, and if you press this button, you jump. You could write a unit test that emulates a spacebar input or whatever, and that then checks if the player has actually jumped. That is a very simple example, but that is essentially what it boils down into. Essentially, it allows you to save yourself from changing one thing that then changes a bunch of other changes down the line. Yeah, as a person in chat puts it succinctly, tests are usually done to make sure that code is still working after modifying it. Yeah, and I'd like to add to that it is actually also possible to use it to test code that you don't actually have other functionality for. For instance, you can use it to test code to check if a certain system works before you're actually able to test it in play mode.
And have you guys seen examples where this saved you a lot of issues, or where the lack of it has caused issues?
Well, definitely in past projects that involved console programming for Nintendo Switch, for Xbox, for PlayStation. A lot of times you have code that does one thing on PC, but that works out slightly differently on another console. Usually because of differences in frame rates and input and stuff like that.
And just having unit testing is a fail-safe.
If we would have had unit testing, it would have cost us or saved us countless hours, probably weeks of development, or man weeks.
Yeah. That's a very good anecdote. At the moment you go across consoles, other platforms, things don't work as you expect them, or they can surprise you, and it can save you weeks of development. Adapting that's a good one.
Yes, there is another question in the chat, and that is unit testing a function that is created, or is it something that existed already? Yeah, it's a function that you'll write. Yeah, I saw Arjen talk in chat about it, in a sense, being metacode. That's completely correct. Unit testing is a form of metacoding. Yeah, so we've taken all of the project code that Vasil is going to cover in a minute here, and we put it on GitHub. So if you would like to play along while Vasil is going over things, feel actually free to download the GitHub repo. If you look in the description of the stream, you can find that there is a link to the GitHub repo.
Hello everyone. So I decided that the best way to show off the code and tests would be to show you the GitHub page that is publicly accessible to everyone. And I've done this whole write up on how to actually do it for yourself and to test tests to put it like that. I can see that there are some questions in the chat. I am just looking at it now. I was troubleshooting the whole time. There was something about breakpoints, and as it was said, breakpoints are for debugging. Once you know there's something wrong in your code, then you can go like point by point, see how your code goes. But a test something you can really customize, that you can make interface with your objects, with your functions, and you can have it pass or not pass. And if it doesn't pass, it actually in Unity gives you a readout. It gives you a little error and it tells you why. And it's much more useful than you just seeing something not working in your game. Because if something is working improperly, debugging tools won't help you, because from the code's perspective, everything is just fine. It's doing what you've told it to do. But from your perspective, the behavior is wrong. And this is where tests are really important when we're thinking about behavior. It's really important that we know on a conceptual level in our mind what behavior should be, and then we describe what behavior should be in code form in our test, and then that test tests your function if it's actually behaving as it should be. And so this is the power of the whole thing. It's very, very useful for open source projects, especially because there's a lot of people providing code. It's super useful for any sort of group or teamwork, especially I can say, for example, in school, if you're working with teammates, of course, it might be difficult to convince them to do unit testing and to write tests. But if everyone is on board, that can make you much more productive, because we've seen that in our experience when working on console ports. This sort of thing really optimizes the whole workflow, because even if you have to give your entire code to someone else to work on and to add stuff, they just need to look at your tests to understand what your functions are supposed to do, and they can actually start maybe trial by error learning what your code does. They can change something and they can see how that affects the results of your tests, which is really, really valuable, because then they can know if they've broken something, and then they can put it back and play around. It gives you much more space for sensing how your code works, for sensing what it does compared to what it's supposed to do. So it's really, really highly recommended. I have a question by Flores. I'm sure you explain more, but I'm curious about more applications for this. In what situations will I implement a test? Ideally, you would implement a test for every single method that you write. So there's a term called code coverage, and that is how much of your code is covered in tests. And of course, the more the better. Being able to write tests for your code means that you have to write some of your functions a little differently, but that's in a very positive way, because you can't just put everything into your update function, or put everything to one function that you just call sometimes. You have to think of your code in a very modular way, in single units and how they fit together. And so I think it's also a really good tool if you're a beginner, even, to just maybe start writing your function normally, but then if you're stuck as to how you're supposed to write the thing that you want it to do, actually go and write a test first. Make the test function as it should, and then based on that you can write your you can write your function, and then you can see if, based on your test, the algorithm you're writing for your function is correct. But ideally, implement a test in every situation that you can. It's a little bit more time, but it really pays dividends in the future once you have to start adding behavior, changing your code. Or if you just leave it for a few months and then you come back, you're always like, what the hell? I have no idea what I was doing. But if you have tests, then you can very quickly get back into it and see how it all works. It's really, really, really valuable in almost all situations. If you're a solo dev and you're like a really god-level pro programmer, you can have everything in your mind. You could be more efficient to just write something, to just put it down. But at some point, no matter how big-brained you are, you will have trouble remembering everything, keeping everything in your mind. And so yes, Floris, use test as does this function, when I do this to it, result in this, is it's doing what I want it to do. And of course, you have multiple tests for a single function. That's the point, and that's something that we do here, which I can now get into. And so here I've written a quick tutorial on how you can make your own test. Especially important in the beginning, the thing that I really can't show you because OBS does not mesh well with Unity on my laptop, is setting up the Unity testing framework, but it's generally pretty simple. You have to open the test runner and you have to make some assembly definitions. But once you have that, you see the test runner, you see how it looks, and it's basically a list of your functions. It's a list of your tests, and then once you run them, you have either an X for not pass or a check mark for pass, and then you know. Yeah. Of course, it's not necessary to have 100% code coverage. There are just like some functions that are so small that do only single-purpose things that maybe you don't need to test all the time, but generally everything that could go wrong, which is most things, you should try to have covered. But of course, don't kill yourself writing tests and stuff. So the example we have here, I want to think of something very simple that also helps showcase why we need to write a test here, despite the fact that this is a simple function. Essentially, I have a class. It tracks health, and it has a function that disables the object that this class is attached to when the cube dies. And of course, that is when the health is exhausted, and the game object is set to false. Very, very basic example. And we'll be writing a test on this function, disable on death. So this is the basic function for this. To go through it, this is pretty similar to the example that I gave. We're testing the function disable on death. We are putting the situation where the HP is empty, the situation where it should die, and we're setting the object to inactive. And of course, this is what we're testing for. We want the object to be set inactive. This is a very basic unit test. Unit being we're testing only a single unit a single unit of your code, a single unit of the cube class even. So just a single function, a single method. This code is pretty simple. I think it's pretty self-explanatory. We're making a generic game object. We're attaching the cube script to it, and then we're working with our script. We're setting the health to 0, and then we're running the disable on that function. Then we are seeing if it's active or not. The active self attribute comes from Unity, and the assert class comes from NUnit, which is the framework on which unit tests are based on for Unity and for C# in general. It's pretty great. You don't need to know much about NUnit particularly to get running to start this, but essentially every test you run will end more or less in an assert function, and then whatever you are asserting, whatever you are comparing, you can test is false, is true. You can test for if it returns an object of the type that you're looking for. You can test for basically whatever you can think of. There's a lot of things you can do with assert, but for now this is more than sufficient. And so if we were to do this properly, we would run the test, and we would see that the test actually fails. Why would the test fail? That's because we forgot to include 0 in the if statement, because we set the health to 0 because in our mind the design is that if the health is 0, the character should be dead, but the way we wrote the function actually is if the health is less than 0, so 0 is not included. Pretty simple mistake to make when programming, and this catches it. Yep, tests are great. And so while this tests that killing the object works, it could be the fact that the object is always inactive, that the object is always dead. So to actually cover the functionality of our function, we need to write another test, which is the one where we do take damage, but the character still stays alive. And that is this one, essentially the same code, but instead of setting the health to 0, we set it to 20. And here we're testing for is true because we want the active state on the game object to remain. Pretty simple. If we test this, it works. This workshop that I've written here includes some code refactoring, because yeah, here we can see when I talk about test cases is that we have two functions essentially that basically share all of this code. So like this and this is shared. So this example is more effective in Visual Studio, where I could actually show you how extract method works. But basically, if you have a lot of code that's repetitive, you can do Control R and then M, and that extracts it to a new function and makes it super neat. And it looks like this. This is basically what it does, and it extracts from us a function which here I've called make fake cube, because we're not making a real cube in the game, we're just making a game object that holds the cube information. The main point here, however, is that while the two tests we did previously test our function and cover things, they only cover for these specific cases. For if the health is 20, close enough, or if for the health is 0. However, there may be a lot of other options, a lot of other edge cases that we want to put in. And so we can use test cases with NUnit, with our unit tests, and they are very simple. Under the test attribute, we can add the test attribute test case, and then between the brackets we can put any sort of value, any sort of variable. In this case, it's a float that contains the HP, and here for the killing test, I am most testing for a negative value. Maybe we are never supposed to get negative values for the health of our character, but in the case that we do, it's important that we have tests that cover it. Ideally, we will also have tests on the functions that call our disable on that function, and then we can also catch if they send negative values, and we can stop it there and fix it there before it reaches here. But for for good code design, it's important that that we also do a comprehensive test of the function. And then for the remains active one, for the still alive but damaged test, I've written a few more as examples. We have one where it's not dead, but it's pretty close. That should still pass. Well, all of these should pass, but the way we had it written is that the float really shouldn't pass, because if you remember when we wrote the original script, we made the health an integer, and now we're sending it a float value here, which would make our test not pass, or even our code not compile. And so, for example, this is something that I was while I was writing and designing this example, I actually did this test and it didn't pass. So this is maybe a mistake that I made myself, and I decided to leave it in here as an example of that this can be quite useful. And then this is not a test, this is just a function. So while our class cube edit tests is in a separate namespace tests, and it's in a separate assembly definition, we can write functions within it that are not tests. We can write just generic functions that do some dirty work for us, that we can then call within the tests themselves. It's always nice to have clean code and clean structure, even in tests. Maybe it's less so important for tests as for production code, but it's always nice to keep things neat and clean. Because also something really important that I have to mention is that the whole point of unit tests, the point that they're small and test in singular units, is that the test should run very quickly. So I'm talking something like under hundreds of a second. Like this test should be able to run basically instantaneously. Maybe we don't necessarily need our test to run in like fractions of a second. Maybe entering play mode is not that big of a deal. But imagine you have a couple of thousand methods, and then each one has 2 or 3 tests each. Then you have thousands and thousands of tests, and if they don't run as quickly as possible, then you're slowing yourself down. Still, that means you can test the whole game in much shorter time than if you were actually manually going and playing the game, which maybe you never test everything, but you really want your tests to be as optimized and as quick as possible, because you're going to be running the whole thing from top to bottom. Yeah, we have an error here which we fixed, which I already talked about. You know, this would have taken a lot longer if I was actually writing it, but thanks to our Corona friends, I guess we're being a bit more efficient today. Essentially, there's a lot more functionality to the Unity test framework, by extension, NUnit itself. There's a lot more things you can do with NUnit. For example, you can have setup functions for your test classes, which set up certain functionality that you want to be there for all of your tests, and then you can have a teardown function, which maybe deletes some objects to optimize things more. And additionally, the Unity test framework on that also lets you run tests within play mode. So the example here was an edit mode test that essentially a test which you can run when the game is not going. You can probably test most, if not all, of your functionality of your game just through edit mode tests, just through simple tests. But play mode tests are very powerful because they let you actually run the game. You can actually tell Unity to run a few frames, and then you can compare things like physics. You can compare gravity. You can compare how your rigid body behaves. Now, those are gonna run slower and they're a bit bigger, so technically not singular unit tests, but they're in the same vein, and for certain games it might still be pretty important to do play mode tests. And there's a lot more things that I'm sure if you're interested, you can go and read into. There's a lot of nice resources about this on Unity's own reference as well. While there are a lot of options, while it's quite a big topic and there's a lot of functionality, what we just did was pretty simple. And I bet for some games that you guys are writing, you probably won't need any more complication than this to write some basic tests. If not to properly cover your code, just to play around with, just to see how it all works, because it's quite an important skill to have. Firstly, because of all the reasons of optimization, of quality of your code, of ease of mind, even while you're programming, but also because being really competent at writing tests is a very good skill to have as a programmer, no matter in what industry you're in. Your code will inherently be easier to work with for others, higher quality, just better. So you will automatically produce better code than anyone else who doesn't do this. And of course, the more you practice, the quicker you are, the better you get, and so the more efficient you become. But that's generally how it works with everything, not necessarily just with programming. Something I put here that's it's kind of cheeky, but very true is if you're not writing tests, you're writing bad code. Of course, for all the reasons that I've said before, but yeah, if you have tests, your code is verifiable. It can be reused instead of things that, having to be rewritten months, years, decades down the line. It lets people sense what your code should do, and it's just great for you. And so while clean code, while pretty looking and easy to read code is great, it's very important as well. If that code doesn't have tests, it's still going to turn into a nightmare sooner or later. That's basically, that's basically the lecture in a very weird GitHub scrolly format. The good thing is that this is available for everyone with our project itself in it. So you can open it in Unity. I did this in the latest version of Unity, so you can download that. It might work in other versions, but you never know with Unity. But whatever the case, you can download this project, open it in your installation of Unity, and you can see how everything is set up. You can play with the test, you can play with the code, you can follow the steps that I have here. If anything is unclear, especially probably around setting up the test framework, and I hope you really I hope that at least a few people start really getting into tests, because it's something that's really, really valuable. I could go back to my PowerPoint to tell everyone to smash the subscribe button, of course, but also that, again, you can reference the lecture at GitHub, and you can always mail me or Anna if you have any questions, maybe about unit testing, if you're interested to talk about something. We're very positive towards students and people who want to learn or are curious about things. We may not answer immediately because we are a bit busy, but we also love talking about people. Right now, I will try to bring back Anna and Aryan on a call, maybe Zoom again or something else that works. And then maybe we could give some anecdotes and some more useful information, and then some final words about it. So see everyone in a bit. Hello, everyone again. Here I am with Anna. Anna, do you think there was anything I specifically missed?
Yeah, there were some questions I saw about what the difference was, and you did talk. What the difference was between using unit tests and using breakpoints.
Oh yeah, this is
and
something you
you,
can explain better
yeah,
than me.
you did talk about how breakpoints are essentially used to track down bugs, and that's quite right. Breakpoints, yeah, you really use that for debugging your code. You use it to track down a glitch or a bug and to fix it, stepping through your code one line of code at a time. While unit testing are more of a general thing, where you use it to put a vice on a piece of code. That is, you use a piece of code to hold another piece of code in place. So, for instance, if you have a player controller where if you press space, you jump, you could then make a unit test that emulates a spacebar press, and that then verifies that if you press spacebar, the character actually does jump. I've also seen another good example in the stream chat talking about how you can use unit testing to make sure that, for instance, a fade out routine that is given an input of 0.5 seconds to fade out actually has completed fading out after 0.5 seconds has passed.
For sure.
Those are very good examples of what unit testing can be used for.
I have the test runner open, so I'll switch over to the other one. Exactly. So here you can see in a very zoomed out version. Here we go. It's a very zoomed in version now, but we can see it better. We can see what the Unity test runner actually looks like. As I said, it's super simple. It basically shows us all of the tests. This is just a default test being made. These are the default names of the two example tests that it comes with. But as you write tests for different functions, you will see them come up here. And if you have test cases, there will be an arrow here, and they will go under your test name. And the naming of the test is very important because essentially most of the time you'll be using your test productively will be here, and it's very useful if you can see what your test is supposed to do and what your test is supposed to. Well, first, what your test is supposed to test. Secondly, what your test is doing with what you're testing, and thirdly, what the expected result for your test is. And then being able to see those things here is very, very useful, especially since in this rectangle over here, you can see more information about the passing or the failing of your test, and it can give you some debugging info. And so that is quite valuable. This is what the test runner looks like. In the GitHub page, I explained it exactly, but I think if you go into like Window General, you can open the test runner. It's very, very, very simple. Back to Aryan. Oh, Aryan's here.
I am, yes.
Hi, Aryan.
Hello. So, and as I am less skilled in development than you guys, and it seems like this is a bit of a hygiene factor. If you build it in your structure, you add tests and do it with a little bit of effort, you have a high gain in preventing issues. Still, it's more
Yes.
effort. So what? Yeah.
Mm-hmm. Yeah. So
How much more work
precisely.
would it be?
Yeah. So I think this is the problem that a lot of people experience when thinking about tests. It's that yes, you have to write some more code, and in the beginning when you're maybe not as experienced with programming in general, that might slow you down a little bit, especially if you're starting a new project. It's very easy to test things. In the example that I gave, it really was not possible to test if our function worked without writing more code. So to test if my cube actually died, I would have to implement some sort of system that would do damage, be it just me pressing spacebar and the health going down, or some sort of
attacking mechanism or gravity or whatever it may be, they'll be writing more code. And so in that example, I really couldn't test it, but that is still a small enough function that maybe you don't need to test it specifically, especially in the beginning. But then as you write more and more functionality for your game, that price that you paid in the beginning to write tests, that extra effort and time that you spent, is really paid back to you, because you can actually sense how your code is running.
Yeah.
It does take a little more time in the beginning, but once your project becomes substantially large, it's really, really valuable to have those tests there. And again, to reiterate the things I said before, especially if you're not working alone, especially if you're in a team, or if you're going to be giving your code to someone else, be it outsourcing, be it a group member or yourself in the future. That's a different person technically, because he would have forgotten everything about what you have been programming. It really helps to get back into it to understand how it works.
Yeah. Yeah,
exactly. Exactly. You write them. Yeah.
Yeah.
We had a very good comment from Flores that you write them, you put them there, and then they keep working, and they keep working for you until the project is done, and potentially in the future as well, when you want to port the project to a different console, or you sell it to someone, and then they have a much easier time understanding your code, or whatever else, or just yourself in 2 months when you've forgotten everything.
Yeah, to kind of surmise what Vasil just said, generally speaking, when you write a system, say in Vasil's instance, you're writing an AI system that controls a character, and that when he takes too much damage, he dies. If you want to test that, you now have to test a function that allows you to test if it actually works. So you'd have to write a function in your update loop that says, well, if I press spacebar, take 10 health off, and then after you press it 10 times, he should die. So you can manually check that. So you can write that code, or you could write a unit test that just deducts 100 damage and then tests that he is actually dead. And whereas the spacebar method is code that you will remove, and if you will want to test it later, or if you make a change in a different script that then causes a whole cascade of changes throughout your entire project, you need to put that test code back in. Whereas with the unit test, it stays. It's a piece that's still there, and you could just forget about it, exactly as Flory said. There's also another factor that Vasil touched on, generally referred to as code rot. If you take a code base from 20 years ago, whether or not you've written it yourself, it will be very difficult to follow what's going on, because code standard change, writing styles change, languages change, whereas with these code tests, or definitely with 20-year-old code, you'd be more talking about comments, you can kind of glean what the original intention of a specific function was. So you can use that to kind of see what the intent was of the original programmer, even if that programmer was yourself, because you do forget.
For sure. Yeah. Something Flor said in the chat is that you might forget to remove the test code. The good thing with the modern test frameworks is that if you set it up properly, your test code would not be included in your builds, in your production code.
Yes, it includes it a completely separate compiled code base. So if you have an edit mode test, the test is only used in edit mode, and the moment you compile it to a console ROM or a .exe, it's not included. It's removed. It's stripped.
You can make
so
it
your
so
test
that
code is not shipped.
Yeah, you can make it so that you can include some tests in builds, but that's something that you can make. It's not the default behavior. So
yeah,
that's something awesome. You don't get bloated build sizes or anything with tests because they're just not included.
Yeah, there is no performance impact in the final game.
Mm-hmm. Oh yeah, he meant that if you added a spacebar for 10 damage, for example. Yeah, for sure. That is something that you have to remove. It's like using using debug.log excessively, for example. That's something you have to add in your code and then take out. But that's a different situation, of course. I feel like we've just about covered the basics. There was a question about the difference between play mode and edit mode tests. I covered it briefly, but from as much as I've used it, you can run your tests. So usually your tests can run either in play mode or edit mode. There wouldn't be a problem, but there are additional features for play mode. Like I said, running a certain time of the game and seeing changes within your scene, or changes that would happen through physics or whatever else, stuff like that. Those are things you don't get in edit mode.
Yeah, if other people still have questions, I guess they can ask them, or perhaps we can end the stream and so people can get on with their day.
Yep. I think
so is there anyone else that would like to ask questions?
I'm just curious, you're mentioning simple mechanics like damage, gravity. Can you also set up a test where you have all the interactions between mechanics tested and whether something goes off the rails?
So it is possible to do that, but that generally is not within the purview of what unit testing is for. Unit testing is for testing simple outcomes, right? Does the damage function work? Does the spacebar jump function work correctly? That sort of thing. And you can use it for more complex interactions, but that is usually more towards automated QA than unit testing.
Yeah.
To kind of fall back to what Vasil said, with a unit test, we're usually talking about something that can run in like less than 100th of a second, 10 milliseconds or so, essentially instantaneously. And the reason why we have these very small, simple tests and not complex ones is because once you have this test runner open in Unity, you click the Run Tests button, and you expect it to run, in a large project, it might run up to 10,000 tests. And you want it to complete in, 2 seconds or less, and not in 15 minutes.
Yeah, it's called unit testing because you're testing the smallest possible units of your code.
It's about granularity. Exactly.
They're testable, and
pretty obvious. Yeah.
The idea is that if you're testing all of your small functions separately, and if they all work as they should, then there shouldn't be any other problems when you just use your functions normally, because the algorithms within them work properly. Of course, maybe you have designed your functions wrong in general, but then that's a problem of you not knowing what you want to do with your code.
All right. Anything else?
It's nice to have Arjen here, because he is not a hardcore programmer himself, so he can give us a perspective from the outside, so to say. So
definitely something to think about for someone like Arjen. If you are not a programmer and you are ever working on a project, say as a producer or as some other kind of team lead or something of that sort, you're ever worried about quality of code and things break constantly, this is something you could also learn to do yourself. The code that you write in code tests is very simple, very short. You don't need to be a very prolific programmer in order to make it work. So it is possible to have your programmers work on specific functions while you give them code tests for what you want them to adhere to.
That would be a great supporting role.
Yes, for instance, if you want a specific UI, that, if you do a certain gesture with your hand, for a VR UI or something like that, when you do a certain gesture, I want this action to happen. Stuff like that you can unit test.
That's actually great. With just answering the question that might have been answered already, it does give me more insight, and hopefully some of the viewers as well. And I'm certainly understanding this whole small scale testing to scaling up in more complex systems and everything. That's little strategies, little tactics to implement in different parts.
In a way, these unit tests, you can kind of view it as kind of a command center overview of the project code.
Yeah.
Right? As somebody who's not a programmer, you can run all the unit tests and you can see exactly if all the code does what it's supposed to do, if there are sufficient unit tests and if there's enough coverage, of course. But you can see kind of if everything is working well, and if there are issues in certain specific parts of the code, then you know what parts of the code have problems without even having to look at the code itself. And another way to view it is that all these units, all these little functions, these little classes here and there, these unit tests, you can also kind of view them as bricks, right? Because anything you build, any building, is ultimately made up of all these bricks. And I think the underlying idea that we're kind of going for here is that if you know for a fact that all the little bricks are good bricks that behave exactly as they should, and they do exactly what you want them to do, then there is a certain level of trust that the whole building as a whole is probably also going to be pretty stable.
Yeah.
Of course, that is not always the case because bricks, buildings don't consist of just bricks. There's, bricks and mortar, and there's a window sometimes, and there's doors and people coming in and out.
There's always bugs in Unity.
Steel girders. Yeah, there is a lot more to a building than just bricks, but bricks is a whole lot of what a building is, if you understand what I'm saying.
Yeah,
you're ruling out certain kinds of bugs.
This goes well with the comment that tests allow us to have a non-destructive workflow because our functions are like bricks and they build together to make the house that is our game. And if we don't have tests and we're changing functions or adding new ones, we are compromising everything else that's attached to it. And if we have tests, it's more like we can see how the house will break based on what we do, so we don't do it. So we don't end up with a broken house where we don't know if we've made the breaking move just now when we edited something or 2 weeks ago when we changed the feature and we had no idea how our change reflected in the overall behavior. But our tests will tell us so. I think generally that's a good point to end it on.
All right. Thank you all so much for showing up today. I'm really surprised by how high the turnout was. We were hoping to get, like 20 viewers or so, but for a big bulk of the stream, we were at 24, 25 viewers. So I'm honestly surprised.
Considering considering the technical issues that we were quite late
absolutely.
because of that.
Yeah, so I'm very happy that so many of you turned out and bothered to sit through us, talk about unit testing and wait for us to get through our technical issues. So I'd like to give a very, very big thank you to all of the people that showed up today.
Absolutely.
It's been a great experience, and I'd hope to see you all for hopefully another lecture sometime in the future.
Please go to the GitHub to check out the project for yourselves. If you need a refresher or if anything was not clear, feel free to look more into unit testing. If you have any questions, you can always ask us. It's Vasil at denofthieves.nl or Anna at denofthieves.nl. We'd love to talk to people. It's something fun. Again, we regret the technical issues, but we know what went wrong this time, so the next guest lecture will be absolutely awesome. I can guarantee that much.
Absolutely.
Thank you very much, everyone. Have a great holiday season. Enjoy your time at home, probably, because everything's in lockdown. And we'll see you all next time. Goodbye.
Goodbye.